All right, so we are going to practice a couple of if, then, because statements. We're going to start on page 12. So when I write an if, then, because statement, my if is always going to be what I am given. So this says if segment BC is a median of triangle ABD, then my then is whatever I would label on the diagram as a result of this. So I know that a median connects a vertex to a midpoint. And if this is a midpoint, then these two pieces are congruent. So my conclusion is that AC is congruent to DC. And then my reasoning, my because, explains what a median is and why that makes me say those segments are congruent. So because a median connects a vertex to a midpoint, and a midpoint splits a segment into two congruent parts. All right. So the second one, the if, says that we have an altitude. So we're going to say if GK is an altitude of triangle HGL. Again, my then is what would I label on this diagram? Well, if I know it's an altitude, it connects a vertex to the opposite side at a right angle. So I would say then, maybe I'd say angle GKH is a right angle, or maybe I'd say that it's congruent to triangle GKL. So I'm going to say maybe that angle GKH is congruent to angle GKL. And then because an altitude is perpendicular to the opposite side and creates two congruent right angles. So notice again, the if is what is given, the then is the conclusion. Often when we're trying to prove triangles congruent, we're trying to the conclusion is ideally that two things are congruent, and that's, what we're trying to identify. And then the because explains why we know that. All right, we're going to do one last one. So if, here's what the given is, if segment CF bisects segment AB at point F, what would I say? So if CF, that's this segment, is bisecting AB, that's this segment, that means it's splitting it in half. So I have two equal parts. So I would say that segment AF is congruent, so then segment AF is congruent to segment BF because, and I need to explain what the word bisects means, but specifically in reference to this segment. So because a segment bisector divides a segment into two equal parts. Okay, so we are going to move on to page 13 here. So when we are trying to create a proof, there's a few things that are happening. The first thing that's happening is we're going to try to label the diagram with all the given. So we're not going to be given just one thing. We're going to be given a couple of pieces of information. We're going to try to label the diagram, and we're going to try to identify if there are congruent triangles, and if so, by what postulate. And then once we've identified all that information, the next step to proving it is creating a string of those if, then, because statements. So right now, let's practice the beginning steps. The beginning steps are, let's take this information and let's get it onto our diagram. So the first thing says that segment AB is congruent to segment CD, so I'm going to mark them congruent. It says that segment BC is congruent to segment DA, so I'm going to mark those congruent. And then this is where I have to look for more detailed information. I have to dig a little deeper. I see that this side is shared between the two triangles. If it's shared, then it's got to be the same size for both triangles. So I can say that it's congruent to itself. Well, then when I look at this triangle, it has a 1 tick, a 2 tick, a 3 tick. And so does this other triangle, a 1 tick, a 2 tick, a 3 tick. So what I can say is, yes, these triangles are congruent by side, side, side. And then what I need to do is I need to label these in the correct order. So I'm going to just match these up for a second. I know that this one and this one go together because it's where the 1 tick and the 2 tick meet, right? Same thing here. I'm going to go ahead and try to mark what else goes together. B, for this one triangle, is where the 2 and the 3 marks tick. The 2 ticks and the 3 ticks meet each other. And then that's where this D is right here. So if I match up A goes to C, B goes to D, and D goes to B. So it's almost as if this triangle has to be rotated to get to become this triangle. All right, now let's look at this one. Let's put this information on our diagram. E is the midpoint of AB, so E is the midpoint, so these two pieces are equal. E is the midpoint of DC, so these two pieces are equal. And then again, I have to look a little closer. What other relationships do I see here? I see that we have two congruent vertical angles here. And so now I see, I have side angle, side congruence. So I just need to go ahead and mark what parts match again. So it looks like A matches with B because they both connect the 1 tick to no ticks, right? So A and B go together, so this is going to be triangle B. Then it looks like the E's are going to go together because that's where the two angles are congruent. So BE, and then the last one would be D. D goes with C. Okay, now when we look at this one, I'm going to go ahead and label this information. So it says B is the midpoint of CD, so these two segments have to be equal. It says that segment AB is equal to segment BE, so these two segments have to be equal. And then it says that AC is perpendicular to CD, so that means that that's a right angle. And ED is perpendicular to CD, so this is a right angle. So I'm thinking to myself, this looks like side-side angle. I know that side-side angle doesn't work as a postulate, but because it's a right triangle, I have to think maybe hypotenuse leg works. This is the hypotenuse, they're both congruent. Here's the leg, they're both congruent. And it is a right triangle, so it does work for hypotenuse leg to be our postulate that says that, yes, these two triangles are congruent. And then again, I'm going to name that congruent statement. ACB goes to triangle EDB. Okay, we have one more example here to do. It says that segment BD is a median of triangle ABC. So I know a median connects a vertex to a midpoint. So if this is a midpoint, that tells me those two sides are congruent. It also tells me that AB and BC are congruent, so I can mark those as equal. And then looking a little deeper, I see, hey, look at this side BD. It has to be the same length for both triangles because it's shared. So I actually see here that I have side, side, side congruence. And I'm going to go ahead and label my postulate. ABD is going to go to CBD. So triangle CBD. So now let's put this all together. We've been practicing all the pieces separately, the postulates, the labeling of the triangles, the writing the if, then, because statements. Let's look at what happens when this all comes together. So the first thing I would do if I were writing a proof would be to take this information, put it on the triangle like we did, figure out what postulate proves that these triangles are congruent. That'd be my first step. The next thing I would do, this is the exact same problem, right? This came from above, so I'm going to just label it the same way we already labeled it, right? So now I would say, okay, here's the information. Here it is on the triangle. I want to prove these triangles are congruent, and I figured out that I can use postulate side, side, side. And I'm going to color code this so that we can see where these all show up. So then I'm going to write 3 if, then, because statements. One that supports each of the parts of the postulate. So let's watch how this works. This first sentence says, given BD is a median of the triangle ABC, then these two sides are congruent, AD and DC, and then it explains why. Because a median goes from a vertex to a midpoint, and a midpoint cuts a segment in half. So this sentence right here directly explains this part of the postulate, that there is this set of sides that are congruent, and here's why. Okay, the second sentence says, also, side AB is congruent to side BC because it is given. This directly explains the second one. Now, because it is given is a perfectly good reason because they gave it to us. We don't have to explain why because that was a given to us. There was no interpreting that we had to do. Okay, and then the very last one says, also, given the diagram, so when we look at the diagram for the relationships, we see that this third side, so this is side 3, is congruent to itself by the reflexive property. Right? Remember that reflexive property says, hey, a side is always going to be congruent to itself. So that explains the third set of sides that are congruent for these two triangles. So let's go in order for a second. AD is congruent to DC, so this set of sides are congruent in these triangles. This set of sides are congruent in these triangles. And then this set of sides is congruent in these triangles because it's the same side. And so then how does this proof end? This proof ends by saying therefore, and we conclude the thing that we were trying to prove, right? We're trying to prove that triangle ADB is congruent to triangle CDB. And then we have to support that, right? Our conclusion is that they are congruent, and I need to state what postulate. So by the side, side, side postulate. So the formula, if you want to call it that, to this proof is that if I'm trying to prove triangles congruent, I need to know my postulate. It tells me exactly what I have to write and in what order to support that the triangles are congruent. All right, we're going to look at one last proof and then we're going to wrap it up for the day. So taking a look at this one, it says that AE is parallel, so this line segment is parallel to DC. Remember, parallel doesn't mean that they're congruent. It just means that they're angled the same way. Now, what we know about parallel lines is that when we have parallel lines, right, a transversal is going to create congruent alternate interior angles. So I know those two angles are congruent. Now, another thing I know this tells me is that segment AC is bisecting segment ED. So ED is being split in half, which means these two segments are the same. It does not mean anything about these two segments, right? ED is the segment that's being split evenly in half. AC is not necessarily. And then if I keep looking, I see to myself, oh, there's also a third thing I know. I know that my vertical angles are going to be congruent because vertical angles are always congruent. So when I look at this, I'm looking and I'm like, okay, I see that these two triangles, they are congruent by angle, side, angle. So I'm going to write this out. I'm going to color code angle, side, angle. So let's read the proof and see how this plays out. It says, given AE is parallel to DC, then angle E is congruent to angle D, because when lines are parallel, alternate interior angles are congruent. So this statement right here, I'm just annotating this so we see it. This explained the first angle. The second statement says, given segment AC bisects segment ED at B, then what were my congruent segments? EB is congruent to DB. And why? Because a segment bisector divides a segment into two congruent segments. Notice there's our second if then because statement. This statement explains why the sides are congruent. And then the next sentence says, also given the diagram, because this was a relationship we see because of the diagram, then angle ABE is congruent to angle CBD, because vertical angles are congruent. Be careful, we can't just call this angle B and angle B, right? We have to name it with the 3 letters. So this sentence explains why the last part of the postulate is congruent, the angles. So notice angle, side, angle, we see this in all 3 sentences here. And then how does it conclude? It concludes by saying, therefore, this triangle is congruent to this triangle by the postulate that we just supported. All of this evidence supports that this postulate works. All right, that's all. On Monday, we will get into our full proof writing. Have a great weekend.